So, in our last explainer, we went over the cloud networking basics. Today, we're taking it a step further. We're going to tackle a problem that, honestly, every developer dreams of having. Your app has gone viral. It's exploding. But now what? How do you actually handle that massive surge in traffic and scale everything effectively? Let's get into it.
Okay, here's our game plan. We're going to start with the challenges of, well, being successful. Then, we'll look at how to direct all that traffic coming in from around the globe. After that, we'll see how to scale your servers up and down automatically, how to plug your own data center into the cloud, and finally, we'll get real about speed, control, and cost.
All right, part 1, the challenges of success. Or, as the subtitle says, that moment when too popular actually becomes a real problem. Yeah, so this is it, the dream scenario. Your app went viral. But what happens next? It's seriously the best problem you can have, but it is still a problem. That single server you had, the one that was doing just fine with a few hundred users, it is now completely overwhelmed. And for your new users, that means the app is slow, it's unresponsive, and for a lot of them, it just won't load at all. Not exactly a great first impression.
And this image pretty much captures the feeling, right? Your server is just drowning. It can't keep up. Every moment it's struggling, you're losing potential customers, and frankly, you're damaging your brand's reputation right out of the gate. So, what's the first step? How do we fix this and keep all those new users happy? That brings us to part 2, directing global traffic. The very first step is to get a whole lot smarter about how you handle all those incoming requests. And to do that, we need to introduce the application load balancer.
So, what is load balancing? Well, at its core, it's the process of distributing network traffic across a bunch of servers so that no single one gets buried. I like to think of it as an expert air traffic controller for your application. It stands at the front gate, sees all the requests coming in, and intelligently routes them to the server that has the most capacity at that very second. The result? A smooth, fast experience for everybody. This diagram shows you exactly how that traffic flows. It all starts with one single entry point. From there, a proxy server takes a look and intelligently directs users to the right group of servers, usually based on the specific URL they're trying to get to. It seems simple, but it's an incredibly powerful way to manage what could easily become a very complex system.
And here is a really key benefit, especially with a global load balancer. You get one single IP address for your entire application. It's called an Anycast IP, which is just a fancy way of saying the same exact address is announced from many different locations all over the world. This is huge because it means you can forget about complex DNS configurations for different regions. It just makes your whole setup so much simpler.
And this slide really nails the global aspect of it. The load balancer automatically figures out where a user is coming from. So if they're in San Francisco, they get sent to the nearest data center on the West Coast. This drastically reduces latency, that's that annoying delay before anything starts to load, and it guarantees that everyone gets a fast, responsive experience no matter where on Earth they are.
Okay, so managing traffic is one piece of the puzzle, but you also need to be able to adjust your actual server capacity on the fly. I mean, how do you add more servers when things are busy, and then get rid of them when traffic dies down so you're not wasting money?
Well, this is where auto-scaling comes in, and it's pretty magical. Think of it like a smart supermarket that can automatically open and close checkout lanes depending on how many people are in line. You only pay for what you actually use, which means you're never burning money on servers that are just sitting around idle. Let's look at a quick example here. The system is watching the CPU usage on your servers. That's a great way to tell how hard they're working. And when it sees that the load is getting too high on these two servers, it automatically adds a brand new one to the pool, just like that. The workload gets spread out, the average CPU usage comes back down, and your app stays perfectly responsive. So how does it know when to kick in? Well, you have a ton of control here. You can set rules based on CPU usage like we just saw, or based on the traffic your load balancer is handling. You can even set up your own custom metrics to watch. You can scale based on the number of jobs in a processing queue, or you can just set a schedule. If you know you have a big launch every Tuesday morning, you can tell it to spin up extra servers ahead of time. It's incredibly flexible.
So far, we've pretty much just been talking about scaling inside the cloud. But what if you have your own data center already? How do you connect your on-premise gear to the cloud and create a hybrid network that really gives you the best of both worlds? This is where something called a point of presence, or POP for short, comes into play. A POP is a real, physical location where you can plug your own private network directly into the cloud provider's massive global network. These are usually inside what are called co-location facilities, basically secure data centers, where lots of companies can put their hardware and connect to each other.
Now, this is a really important thing to remember. While the cloud provider gives you the entry point, the POP, it's your responsibility to get the physical connection from your data center to that POP. Think of the POP as the front door to Google's network. They provide the door, but you have to run the cable all the way to their doorstep.
And you've got a few different ways to make that connection. A VPN is a great place to start. It's secure and runs over the public internet. But for more serious applications, you probably look at a partner or a dedicated interconnect. These options give you a private, high-speed connection that's way more reliable and performs much more consistently. It's like having your own private highway into the cloud.
All right, so these solutions give you incredible performance and control, but they also come with costs, and it's really important to be aware of them. So let's look at those trade-offs between speed, control, and cost.
Here's a key concept in cloud pricing you absolutely have to know. Generally, you don't pay to put data into the cloud, but you almost always pay to take data out of the cloud. This is called egress. And if your app, say, streams a lot of video, you're going to be transferring a lot of data out to your users. That egress can become a pretty significant cost.
So if you need to move massive amounts of data between your own data center and the cloud, and you need the best possible performance and security, well, a dedicated interconnect is the answer. It is a premium solution for sure, but it's for those mission-critical applications where every single millisecond counts. So by putting together a combination of global load balancing, automatic scaling, and the right connection strategy for you, you can build a network that is truly ready for anything. So the final question really isn't just whether your app is ready for its users, it's whether your network is ready for your app's success. Thanks for joining me on this explainer.